All right, we're going to start with 5-1 through 5-4. First thing we're going to do is 5-1, which is mid-segments. The mid-segment of a triangle is a segment whose endpoints are the midpoints of two sides of a triangle. So, if B, since B is the midpoint of AC, I should mark that, those parts as congruent, AB and CB. And then, if point E is the midpoint of AD, then I should mark AE congruent to DE. All right? Then that makes BE a mid-segment because it joined two midpoints, B and E. All right, here was your midpoints. Okay. So your triangle mid-segment theorem says if a segment joins the midpoints of the two sides of a triangle, then the segment is parallel to the third side and is half as long. So if B and D are midpoints, and we know they're midpoints because of these congruency markings right there, then we know that BD is parallel to AE, and BD would be half as long as AE. So if AE was 10, for instance, we would know BD would be 5. You can just remember your short one and your long one, and the short one should be half of the long one. All right, so this first example, let's do one with it. What are the three pairs of parallel segments in triangle DEF? Well, to start, we should identify what the midsegments are. So look for indications that the endpoints of a segment are the midpoints of a side. All right, so R is a midpoint because those are marked as congruent. S is also a midpoint because we have these marked as congruent, and T is also a midpoint. So then our midsegments would be RS, ST, and TR. So RS, ST, and TR are all mid-segments. Step 2, using the triangle mid-segment theorem, which segments are those three mid-segments listed above parallel to? So RS right here, you can almost just go off looks with this too. Which one looks like it would never intersect RS would be DF right here. Those ones would be parallel. All right, we can also then go to ST right here, and the one that would be parallel is ED. And then lastly, we can look at TR right here, which should be parallel to EF. All right, so you can know all of those segments are parallel based off your mid-segment theorem.
Okay, next up we're going to talk about a perpendicular bisector. This is a line, ray, or line segment that is perpendicular. Remember, that is our symbol for perpendicular to a segment and intersects at the midpoint. All right, so it has to cross it at a 90-degree angle, and it has to cut the side in half. All right, so any point on the perpendicular bisector of a segment is equidistant from the endpoints of the segment. It means no matter where I draw or put a dot on this line, it is going to be the same distance away from C as it is from B. So just as an example, if I told you that AC was 5, then AB would also be 5. All right? And the converse is true as well. Any point that is equidistant from the endpoints of a segment lie on the perpendicular bisector. That's just taking the order and flipping it around. Means the exact same thing. All right? For our first example here, what is the length of AB? And they want us to explain. So we know that this side's been cut in half, and we know that we have a perpendicular there. So that means that that line is the perpendicular bisector. What that means is now it's actually created this triangle to be an isosceles triangle, which means these two sides have to be congruent to each other, all right? Because they're equidistant away, right? So we know that 4x is equal to 6x minus 10. And if we want to start solving, we got to just go ahead and move the 6x over by subtracting it. We get negative 2x equals negative 10. Lastly, we go ahead and divide by -2, and x equals 5. Now, a lot of people automatically assume that you're done at this point, but remember, they're asking us to solve for AB here, so I need to plug it in for x. So I take 4, put the 5 in for x, and we get an answer of 20 for our final answer. All right? The next one we're going to talk about is an angle bisector. Of course, you've heard this term before by now, I'm sure. But it's any ray, line, or line segment that cuts an angle into two congruent angles. All right? So what that means is this angle over here has now been cut into two pieces that we know are congruent. So if I know one angle is 30, the other one would have to be 30, so on and so forth. All right? Now, the theorem that we're going to learn with this is the angle bisector theorem. What this says is any point that is on the angle bisector is equidistant from both sides of the angle. All right? So just an example, that means if I told you, so we have an angle here, then we have the angle bisector going down the center, that means that these two pieces would then be congruent. So if I said that this is 6, this would also be 6, all right? That's all it means for that. So we have equal distance away from it if it's the angle bisector. Also with that, you have the converse. It says if a point on the interior of an angle is equidistant from both sides of the angle, then it lies on the angle bisector. So that's just taking it and flipping the order around and saying that if that happens, then we know the angle has then been cut in half. All right? So let's use that for our example here at the bottom. It says, what is the length of FB? FB is this piece right here. So we need to find the length of that. The key with this is, do we have an angle bisector? Yeah, because the angle's been cut in half down there, right? Which means if that is an angle bisector, then we know that this piece is congruent to this piece. So if we want to solve it, we can say that 6x plus 3 is equal to 4x plus 9. And then from here, it's just a little bit of algebra work. First thing I need to do is move my 4x over by subtraction. We get 2x plus 3 equals 9. Then we subtract 3, we get 2x equals 6. Then lastly, we divide by 2, so x equals 3. Again, don't get this wrong because you forget to plug it back in, which is what we're seeing on a lot of our tests. So we need to make sure that we plug it back in for FB, which is 6x plus 3. So we take 6, take the x out, put 3 in, and then add 3 to it. So 6 times 3 plus 3 would equal 21. So the length of FB would equal 21. All right?
All right, the last part we're going to learn about medians and altitudes. A median is a segment whose endpoints are the vertex of a triangle and the midpoint of the opposite side of the vertex. So right here, this point at the top of our triangle, that is called a vertex. And then right here, we know would be a midpoint because of those congruency markings. So then, this line right here is a median. All right. We also have altitudes. An altitude is the perpendicular line segment from a vertex to the opposite side. It can be inside or outside the triangle, or it can actually be a side of the triangle. I'll give you what a few of those look like. So if it is inside the triangle, it will look like this. It goes from a vertex and then is perpendicular to the opposite side. So this line right here would be your altitude. If it was outside of the triangle, you would have a picture that might look like this. Now, if I want to go from this vertex to go straight down to make a 90-degree angle, I would actually be outside of the triangle. So this right here is my altitude, even though it's outside of the triangle. The last option you might have is this, where you have a right triangle. If I go from this vertex and I want to go straight down to make a perpendicular, I'm actually using that side of the triangle, and it makes this my altitude. Okay, so make sure you can recognize an altitude from a vertex perpendicular to the opposite side, whether it is inside, outside, or aside. All right, let's do some examples using this. So for triangle ABC, is each segment in a median, an altitude, or neither? And explain. All right, AD is right here. First, ask yourself, do you go from a vertex? Are you at a point of the triangle? You are. And then look at your other side. Are you either a right angle for an altitude or a midpoint for a median? If you know these are congruent, then you know D is a midpoint, so AD then becomes a median. All right, then we can look at EG. E is a midpoint because those are marked as congruent, but then your opposite side, is that at a vertex? It is not, it's just on a side of the figure, so that will be neither. Since it does not go from a vertex, it is not a median. And then lastly, let's look at CF. CF is right here. I see a right angle, which is good for an altitude, and it needs to go from a vertex to the opposite side, which it does, so then CF is an altitude. All right, and then some solving kinds of problems that you might get with altitudes and medians. If you know that AK is an altitude for triangle ABC, mark on your picture what that means. A is at a vertex, so then at K, it needs to be perpendicular if it's an altitude. So I can put that in my picture. Now, solve for X if angle AKC is 5x minus 10. AKC means 5x minus 10 is right here. Remember that middle letter is where your angle is at, but the A and the C tell you which angle it specifically is. All right, so then how would you solve? Well, I know that 5x minus 10 is equal to 90 degrees because an altitude made that 90-degree angle. So to solve, we will add 10, 5x equals 100, divide by 5, and x is 20. It just said to solve for x, so you are done. With the next problem, AK is a median for triangle ABC. So A is at the vertex, so then at K, I should be at a midpoint, which means I should draw in those congruencies. So now, what is the length of BC if KC is 64? So I want to find what all of BC is if I know from K to C is 64. Well, because I drew in these congruencies, because I knew K was a midpoint, I can put 64 here, and then part plus part will equal my whole. So BC equals 128. All right, that's how you'll use midsegments, perpendicular and angle bisectors, medians, and altitudes. We'll practice this more in class.